So we're back with this glorious beast, the ESP8266 outdoor temperature sensor. Now, it's been a pain, but a brilliantly fun pain. So after last time, I realized that my batteries were draining at about 2.5 milliamps per hour. So that was the current this thing was drawing. We did a live stream as well, looking at some of the possibilities of using an AT-Tiny85 to switch on the ESP8266, which is what I've implemented here. Now, there is a problem, and it's Mosfets. Turns out I don't know much about Mosfets. Since I didn't have an education in electronics, I didn't do a degree in it, or, well, I don't even think we learnt very much at school. I've sort of skipped over Mosfets and transistors. I know what they do, I know generally what they do, but all the different attributes like RDS on or threshold voltage, gate to source, all that kind of stuff is like hidden to me because I don't really understand it. But I've been reading a lot recently, and also you guys have been helping me out an awful lot. So I'm starting to understand, and hopefully I do already understand how all of that stuff links in together. Now, I've implemented a solution here using a crappy Mosfet, an N-channel Mosfet, which isn't going to work very well. It is the BS170, and unfortunately it has a rather high RDS on, so it's going to pull the voltage down a little bit on the ESP8266, but not by a massive amount. But I just need to get a better one, hopefully. But it isn't everything. So it also has this threshold voltage, and the threshold voltage is about how much voltage you need to put into that MOSFET to turn it on. Now, MOSFETs are voltage devices and transistors are current devices. So when you start a MOSFET, it needs to be a high enough voltage to get that MOSFET to go. And you also have a gate to source differential as well that you need to worry about. There are lots of things that I don't quite understand, so I'm not going to try and explain it to you. I'm sure some of you will understand it better than I. So I'm working on figuring it all out. However, what I need to do now is go away and figure out which MOSFETs are going to work for me. The BS170 is a logic level MOSFET, so its gate threshold is low enough to be triggered by the batteries, and it should make the ESP8266 work for a while. However, the lower these batteries drop, the less likely it is that the ESP8266 will operate properly. And that's because of the resistance over the gate and source. So it will just drop that voltage too much, and then the regulator on the board will not work properly. So we'll see how it works out. These batteries are now fully charged, so it should work for a little while. We're going to turn it on in a second and then put it outside again, and you'll be able to see on the graph as it works how long it's going to last for. It's going to be updating at every 30 minutes, and the AT-Tiny85 is going to be turning it on. So it is going into sleep mode, the AT-Tiny85. It's waking up with the watchdog timer. It's using the interrupt service routine to increment a counter, and that's counting up to 30 minutes because you can only sleep for 8 seconds on the AT-Tiny85. So let's have a look at what's going on a diagram. I'm going to have to draw one, but that's okay. It'll just be a really terrible drawing, and hopefully you guys will be able to make sense of it. So we're going to use block diagrams because it's a bit easier. So if I start here, we've got the ESP-12. That's going to BAT plus. Now that's going through the AMS 1111117. It's a few more ones than that. I think I've missed a couple out. And then it's going into our MOSFET. And I really hope I draw the right kind. I should have done this beforehand. But it's an N-channel MOSFET. And I'm pretty sure this is right. And so we've got our gate source drain, and then on the gate, I'll move this up a little bit, we're going to ground with a 10k resistor just to hold that MOSFET off. And then we've got our AT-Tiny85 here, so it should put AT85. And then on pin 2, we have it turning on this MOSFET when it needs to. Of course, that's grounded over here. We've also got ground on the 801085 and BAT+. But how do we know when the ESP12 is finished? Well, we've got a line coming from the ESP12 over to pin 4 of the 801085. When that line goes high, the 801085 knows it can turn off that MOSFET and go to sleep. This is coming from GPIO 14 on there. I think that's everything. I mean, it's all on horrible breadboards, so as you can imagine, there's going to be some resistances in these wires. Not an awful lot, but enough to drop a few millivolts, I would imagine. So it may cause some issues. However, I'm hoping it will work for a little while at least, while I figure out which MOSFETs are the best and whether there's a different solution that I can use. Oh, we did sort of just miss out that bit there. There's a line there. Anyway, thank you very much for all the tips and stuff. I've really appreciated it. I would love to know if anyone's done this before. I know a lot of people would rather just take the voltage regulator off. However, I'm pretty sure there are loads of boards out there with these AMS 111117s on. So I think it'd be nice to find a little solution that deals with that. And for any microcontroller that you can't bring down to a really low sleep current because you have a voltage regulator or something like that. So, thank you very much. Oh, do you like the new mat? It's nice, isn't it? It's a lovely purple number. So I thought I'd just switch it up a little bit. Anyway, thank you very much, and I'll speak to you soon.